Hi, if I need to graph a system of linear inequalities, if I have this question, graph the system of linear inequalities, give two ordered pairs that are solution and two that are not solution. I have minus 6x plus 3y less than or equal 12 and y greater than half x minus 3. First, I cannot graph it like this because it's already in the standard form. I cannot graph it while it's in the standard form. I have to change it into slope-intercept form. Slope-intercept form, which is y equal mx plus b. But this is actually is not slope-intercept form. This is a standard form, ax plus by equal to c. So I will change it into slope-intercept form. Now, if I need to change this one to this one, I need to isolate the y. So if I need to isolate y, I will bring the negative 6x to the other side. So it will become 3y less than or equal, negative 6x will go positive 6x plus 12. Now I need to isolate y, so I divide all the sides by 3. Now my new equation is, now this is y less than or equal 2x plus 4. The second one remains as it is, y greater than half x minus 3. Now I will go to the second step, which is graphing. But before I graph, I have to remember one thing, these symbols. Now these inequality symbols, what about them? Now if I have greater than or equal, then when I shade now, I will shade up. And if I have less than or equal, I will shade down. Now if I have greater than or less than, then my line will be a dotted line. Now if I have greater than or equal or less than or equal, my line will be a solid line. Now for graphing, first I have to know where is the b and where is the m. This is the b actually, because we said y equal mx plus b. So this is the b. B is actually the y-intercept. And this is the m, which is always to equal rise over run. Now for the rise and the run, the rise, if it's positive, you go up. If it's negative, you go down. And also the run. When the run is positive, you go to the right. When it's negative, you go to the left. Now I have everything in front of me. Now if I need to graph this one now, first I have to know what is my b and what is my m. Here the b is 4. So this is my b, which is 4. And this is 0 and 4, it means. This is the y-intercept. I always graph it on the y-axis because always x for the y-intercept is always 0. So we graph it on the y-axis. And actually m here is 2. Actually write it 2 over 1. Now 2 is positive, means you will go up. As we said, it's rise over run. And if the rise is positive, you go up. So you will go 2 up. And then you will go 1 to the right. Then I will do the same here. B is negative 3. I take it with its sign. So it's 0 and negative 3 on the y-axis. Then I will do my m. M equal 1 over 2. 1 is positive, this is the rise, so you go up. And 2 is positive, this is the run, you go to the right. Now I will take my graph and I will start graphing. I will do these information, I will put them here. First I will put my b, 0 and 4, so I will go up here on the y-axis as we said. Then I have to go 2 up and 1 to the right. So I go 2 up and then 1 to the right, it's here. Then I connect them with my ruler. I should have my ruler with me. Then I will go and connect these two together. These 2 points, I will connect them together. Oh, here. Should be a straight line, of course. So this is my line. should be extended as much as I can. Here should be a straight line, but it's little because I'm taking the video. Now second one, I will put my -3. Take care on the y-axis, so I will go down here. It's -3. Then I will go 1 up, and then 2 to the right. 1, 2. It's here. Then I will connect my second point like this. Now, while you are graphing, take care from your lines. Now, in the first line here, I graphed the first line, which is actually less than or equal, and as we said before, if I have less than or equal, it's a solid line. For this, I graphed the first one as a solid line. This first one, I graphed it as a solid line. But this one, it should be a dotted line. Why? Because, as we said before, this greater than, it's a dotted line, but this one is a solid line. So the first one I graphed it as a solid line, but the second one I will graph it as a dotted line. I will start by putting my M and B. I put them. Now I have to connect them together, but take care, your line should be a dotted line like this. Of course, it's a hard little to graph while I'm holding my camera. Should be a dotted line like this. Now, try to extend it as much as you can. Now, here, I have now my 2 lines, okay? Now, I need now to do the shading. Now, the first one, my answer was less than or equal. So when we have less than, we said before, less than, it means shade down. So I will shade the first one that we have before, the solid line, which has this solid line. I will shade it down here, like this. Try to make it a straight line here. All these will be my shading. Now for the second one, it's like this. This is greater than. Greater than is shading up. So the second one, I will shade it up like this. Now this area in the middle, this area has the overlapping between the first graph and the second graph. So both of them overlap here. Both of them overlap here. If they overlap here, it means this is the area of the solution. Any ordered pairs that are in this area, they are solution. Any ordered pairs that are not in this area, they are not solutions. So if I choose any ordered pair here, it will be a solution. Now, if I need to choose any ordered pair, you can choose any ordered pair within this region of overlapping, or even on the solid line. Any point on the solid line is a solution. Any point on the solid line is a solution, but any point in the dotted line is not a solution. Any point in the solid line is a solution, but any point that is in the solid line is not actually a solution. So I can choose any point on the solid line or in the region between them. So all the possible solutions are all of the ordered pairs that lie in the region shared by the 2 inequalities and on the solid line boundary. Now, I can choose any points here that are solutions. For example, if I choose 3 and 2, this is a solution. If I choose here 0 and 0, it's a solution. All these points actually are solutions. Now, if I choose also, for example, points that are not solution, I can choose -4 and 2 because it's outside the overlapping area. -4 and -2, for example, 6 and -1. I can choose any point. Even if I choose any point on the solid line, it's also not a solution. So I can write here, for example, I can choose any points I like. For example, if I choose 2 and 8, it comes exactly on the solid line. So it's also a solution. 2 and 8 is a solution. 0 and 0 is a solution. Many points. So I can write here that I have, for example, 2 and 8, 0, 0 are solutions. Then I can say that I can choose any points that are not solutions. For example, -6 and -4. These are not solution. -4 and, for example, 4. It's not a solution. I can choose whatever points I like. So I will say -6 and -4 are, and also -4 and 4 are not solutions. This is all. I finished my question. I have all my answer here. I have my graph here, and everything is done. Thank you.